Okay, we're going to start lesson 1.3 today on line segments. The objective here is to apply this concept of betweenness of points to calculate measures of line segments. And the betweenness of points concept we also call the segment addition postulate, and I'll show you that here in a minute. We're also going to apply the definition of congruent line segments to find some missing values. All right, so first of all, just a quick review. The line segment concept, measurable part of a line that consists of two endpoints and all the points in between. Okay, so if you had this drawing where you can see that it's a line, but you can also see there's parts of it that makes it a line segment. So you can see, for instance, we would have segment XY would be this measurable distance from X to Y. You got segment YX is the same thing. We got segment YZ, which you could also call ZY. You got segment XZ, and you could also call that at segment ZX. So, these two are the same segment, these two, just the order is changed, but it doesn't change that part. Okay, so that's just a little bit of review of, what we do and how we label and correctly show line segments. All right, this idea of betweenness of points, which is also called the segment addition postulate, okay, it reads like this. So if we got point C and we know it's between A and B, then it is between A and B if and only if A, B, and C are collinear. And if you were to take AC plus CB, it would have to equal AB. Now, I want to point something out here real quick. When we write two letters next to each other like this, AC, this represents the distance from AC, A to C, point A to point C, and that's a number. So AC is really a number. CB is the number, that's the distance, represents the distance from C to B. And AB is the number, the distance from A to B. That's why we can write this in an equation. See, notice up here, they had a segment symbol above it. So that represents a geometric drawing. This represents a distance. Okay. So if we look over here, we got segment AC plus segment CB is going to equal segment AB. So if I add this segment plus this segment, it equals the entire length. Sounds like a real simple concept, and it really is, but we'll use this quite a bit. Okay. All right, so let's talk about how we're going to use this tonight a little bit. So find the measure of each segment. Now I know what you guys can quickly just add these two together and say EF is whatever that may be. But we want to get in the habit of understanding how to use this geometry and how we can use it with algebra. So for example, the way we like to write it is say, you know what, based on this drawing, I know that EG, that length, plus GF has got to equal EF. All right, so EG, substituted in 2.5, and again this represented a number, so I can replace it with a number, plus G to F, which is 2.8, has got to equal E to F, which is what we're trying to find. So now I got a nice simple mathematical statement. I know that if I add 2.5 and 2.8, I'm going to get the length of EF, and that's 5.3. So E to F is 5.3. All right, looking over here, now it's a little different, but this is why I like to write this statement to begin with. So just looking at the drawing, okay, we should see that if I take HJ and add JK, that's going to equal HK, the whole length. Okay, now substitute in what you know. So we know that H to J, well, we don't know that. That's our unknown, right? So we're going to leave this HJ here. We know J to K is 3.1. Okay, I guess I did it a little differently, guys. Sorry. What I did here is we were looking to find HJ. So I solved this like an equation first. And so what I did is to isolate HG, I subtracted JK from both sides. That's where this line comes from. And then I substituted. Okay, H to K is 12.2. J to K is 3.1. I now know HJ is going to be equal to the difference of these two values. So HJ is going to be 9.1. Okay, so I could have substituted the numbers here and then done the subtraction. I got to the same place, but I did the subtraction with some variables up here, and I'm going to get the same result. Okay, so that's a little bit of segment addition. You're going to have some of those tonight. Okay, the next thing is, what if they don't give us a drawing? So in this case, they just tell us find the value of the variable and find the length of y to z if y is between x and z. All right, so that's kind of vague if you're not doing what we just talked about. So what I want to do is I want to create a drawing first. So here's what they described to me. Y is between x and z. So y is between x and z. If I write a segment addition postulate to represent this, I would say xy, this distance, plus yz, this distance, equals the full distance x to z. These two segments add up to the overall. Now, this is what we'll use down here for these. They give me the information. All I got to do is write my equation, substitute it in, solve. Okay? Because we're talking about the same x, y, and z in the drawing for each of these. So let's start over here. We know xy plus yz equals xz. We're taking that from the drawing, and that's from the description. All right, we know xy is 11. We know yz is 4c. We know x to z is 83. We got ourselves a little two-step equation to solve. So the first thing we would do is subtract 11 from both sides. 4c equals 72. Divide both sides by 4, and c equals 18. Now remember, in the directions it said find the value of the variable and then find the distance from y to z. So the distance from y to z is 4c. I know c is 18, so we're going to plug 18 in place of the c. Final answer here for this part of it is yz is 72. So you're going to need both these two answers to correctly get this one. Okay, same directions follow over here. This is a little bit more complicated because they use some expressions here rather than just numbers. Okay, but it's the same concept. All right, we know that xy plus yz equals xz. So I took 3k minus 2 plus 7k plus 4 equals 4k plus 38. I substituted them in. Okay, combine like terms. 3k and 7k are 10k. Negative 2 and positive 4 is positive 2. I still have 4k plus 38 on the other side. So first step in solving is to combine like terms to simplify the left side. Okay, subtract 4k from both sides. 6k is 36. Okay, I guess I subtracted 2 also at the same time. You guys can do this by now. But notice that every line of work I'm writing is equivalent to the one above. So you have to complete that process. Okay, divide each side by 6, and k is 6. Okay, so remember they said you got to find the value of the variable and y to z. So I got the value of the variable. Now I got to get y to z. Well, y to z is 7k plus 4. That's the expression they give us. We now know k is 6, so that's 7 times 6 plus 4, 42 plus 4, so y to z is 46. Okay, pretty straightforward stuff. Okay, now how about this one? A little more application of the segment addition, but now as you look up here, uh, if you look at number 5, look at the drawing. So I got PQ, QR, RS, and ST, and what they're showing here, these markings, sometimes called tick marks. Okay, the tick marks match up. They all have one slash through them. That means all of these are the same length. So the distance from P to Q is the same as Q to R, is the same as R to S, and S to T. Okay, they're asking us to find QT. So we know that, again, PQ is equal to QR is equal to RS is equal to ST. Well, what do we know about QT? Well, I guess let's do this first. We know that these 4 segments, I can use a segment addition for more than 2 segments. So in this case, I know that PQ plus QR plus RS plus ST has to equal the full length, which is PT. Okay. We know that Q to T is 3 of these 4 equal pieces. Okay. So the distance from Q to T is 3/4 of the distance of P to T. Okay. I pulled that equation out by looking up here. Okay. Now, what do we know the distance from P to T is? We know it's 14.4. We're going to take 3/4 of 14.4. How do we do that? Okay. Well, really what this means is take 14.4 divided by 4 and then multiply the answer by 3. Or you can, in a calculator, do 3/4 times 14.4. Your answer is 10.8. So Q to T is 10.8. Okay. There's several different ways you could have done this. Okay. You could have taken 14.4, divided it by 4, and then you would have had 3 of those. Well, guess what? That's what I just did right here. 14.4 divided by 4 times 3. But you could have written it out differently, and I'll accept that. This isn't the only way you can do it. Okay, let's move over to number 6. This should be. All right, they want us to find u to x. So u to x. Now again, see the markings here? That means that these three are all the same length. U to v is the same as v to w is the same as w to x. Now, since they all have a variable x in them, what I can do is pick any two and set them equal to each other. So for instance, u to v and v to w, they're the same length. So these two expressions have to equal each other. It won't matter which two you set equal, you're going to get the same answer. Okay, so what we'll do here, subtract 3x and add 6, and we get x equals 7. Okay, so now they want us to find u to x. Well, what does that mean? Well, here's what I did. I found u to v. Okay, I put a 7 in place of x in the expression. I did the calculations. I got u to v be 22. Now, all of these are 22s. So then I said, you know what? All of these are the same. They're all 22s. So u to x has got to be 66. And you could have written that different ways, guys. But the key is you're writing it out so that it's clear and you show me that you understand it. Okay. But that's the general idea. That's what we get out of these markings is congruent segments. Okay. There's more information. If you go to your McGraw-Hill textbook and go through this lesson, you'll see more examples and ideas in there that will help you with it. Tonight you're going to have homework, and tonight's homework is actually on the McGraw-Hill site. So that link's provided on the on the virtual web page, so you won't have any trouble getting to it. But make sure you get that homework done, and I'll let you guys get to it.